Welcome everybody. This is the second part of lesson 6.2, 6.3 for my grade 11 applied students. And okay, here it is. We're finally going to graph three different equations. Okay, how do we want to do this? I'm a big fan. No, we didn't do this one. Somebody's saying we did this one yesterday. No, we didn't. We stopped on the example before this. And you must have worked ahead. Good for you. Let's see if we got the same answer. I'm a big fan of graphing these using y equals mx plus b. So this one's already in that form. This one's just a vertical line. I don't need to change it any. And maybe, in fact, I'll do those ones first. I'm going to do this one. I'll do this in a purple. So y is greater than or equal to -3. So that is the vertical line. And I have to draw this really carefully. This is the vertical line that goes through when x is -3. And I want greater than. X is greater than -3. So that's everything shaded to the left. So I'm going to write down shade left. You with me so far? Okay, now this one's already also ready to go. I'm going to do this in blue. It has a y-intercept of 4. And it has a slope. Now remember this number here. I don't even think of it as a fraction. I think of it as two different numbers. I rise 4 and I run 1. Both of those numbers are positive. Which way is positive when you're rising? Up. Which way is positive when you're running? To the right. So from this dot, go up 4 and right. Oh, that's supposed to be a 3, not a 1. Sorry. Thank you. So rise 4 and run 3. 1, 2, 3, 4, 1, 2, 3. Okay, I'm kind of out of room, so I'll go backwards. Backwards would be down 4 and left 3. Hey, they actually meet right there, which is kind of cool. Now, this one was a solid line because of the equal. This one's also a solid line, so I'm going to connect the dots with a solid line. I'm not shading yet, and I'll show you why in a minute. Oh, whoops. Thank you. That's a typo. As in, I wrote it down wrong because I was falling asleep. You are correct. That should be shade to the right. Thank you. Greater than. Sorry. I need more coffee. Okay. Let me go backwards again. What was the thing again? Down 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And solid line, solid line, solid line, solid line. Now, we're not going to shade yet, but let's figure out where we shade. Does it go through 0, 0? No. So then that's the point I'm going to use for my test. Testing. Does 0, 0 belong in the set or not? 0 is less than or equal to 4/3 of 0 plus 4. Well, anything times 0 is 0. So is 0 less than or equal to 4? Is that true or false? It's true. So therefore 0, 0 is in the set. So I'm going to shade. I'll say, you could say either right or down. Both of them would be okay. I'll say down, right? Down from this line, this way, shading in here. Okay, so I'm shading to the right of this and down from that, but I got one more line to go, and this one needs some work. I have to pick a strategy for graphing this equation. I kind of like changing it to y equals mx plus b, but that's not the only way that's easy. The other way that's easy is notice that 1 and 3 are both factors of 6. I could do the intercepts method if you like. Okay, either one works. I'll stick with this one because I'm kind of having some success with this one today, except for that one little mistake I made. So let's rearrange this one. So -3y, I'm going to add x to both sides of the equation. There we go. Then I got one more step. I have to divide both sides of the equation by -3. Now remember that x does have a number in front of it. Right? There's an invisible number here. Can you see it? Yep. There's a 1. What do you get when you divide 1 by -3? You get -1/3. I don't want no decimals because, again, I want a rise and a run. Think of it as two numbers rather than a fraction if you're not a big fraction fan. 6 divided by -3 is -2. There, we divided both sides of the equation by -3. But what happens when you divide an inequality by a negative? You flip the direction of the inequality. How did I get this? Okay, what did I do first? I added x to both sides, so now it's over here.
If you divide by a
If you divide both sides of an inequality by a negative, it flips the direction of the inequality. Same thing with multiply. If you multiply or divide both sides of an inequality by a negative, it becomes its opposite direction. Okay, so let's graph this guy now. Its y-axis, its y-intercept is -2, right? -1, -2. And then, okay, my rise over run is -1/3. So that's my rise, and that's my run. If I'm going in the y direction negatively, am I going up or down? I'm going down. So this is down 1 and right 3. So go from this dot, go down 1 and right 3. Down 1 and right 3. Down 1 and right 3. I'd like to go the other way now. What did I? No. Okay, good question. If I decided I wanted to go left, that means that this negative is being used down here, and then the top's not negative anymore. So then I would say that I'm going up 1 and left 3. Notice I can't use a negative on the top and on the bottom because the negative divided by negative is a positive. It wouldn't be the same number. So this, by the way, is the way I want to think about it now because I'm kind of out of room going that way. So starting from this point, go up 1 and left 3, up 1 and left 3, up 1 and left 3, and there we go. There is, now what kind of a line is this one? Dashed line, right? Because there's no equals on it. So make sure you make a dashed line. You can ask whatever you like.
Could you re-explain how you got the y is greater than negative?
Because that's a rule you just have to remember. We're not going to give you that one on a test. You have to know this. You were supposed to know it back in grade 9. When you were dealing with an inequality and you multiply or divide both sides by a negative, it reverses the inequality. It makes it flip. Question?
Why is it -1 divided by 3, not 1 divided by negative?
Because it doesn't really matter where you put the negative on a fraction. All of these things are all -0.3 repeating, right? A negative divided by a positive is a negative. A positive divided by a negative is a negative. And if I take a positive divided by a positive, get an answer, and make a negative, they're all the same fraction. So normally when I'm doing fractions, I usually, if I have a negative, assign it to the numerator. That's just kind of a traditional thing math people do, because when you're working with fractions, unless you're multiplying or dividing, the denominator stays the same anyway, right? Remember, when you add fractions, you get a common denominator, then you leave it alone. So putting negatives in the denominator is usually not useful. So that's why we just get used to not doing it. How do you get the -2? I divided both sides of this equation by -3. So 1 got divided by -3, 6 got divided by -3. Okay, now we're not done with the green guy yet because we haven't figured out which way we're shading. So once again, does it go through 0, 0? No, so I'm going to test 0, 0. And you go back to the original equation. What was the original equation again? Oh, there it is. So -3 times 0 minus another 0 is greater than 6. Is that true? Is 0 greater than 6? No. So 0, 0 is not in the test zone. So that means I'm shading down. So shade down. Okay, put all three of these together. We are shading right for the purple line. We're shading down from the blue line. And we're shading down from the green line.
This takes more pro.
Because its x is greater than -3. Which way is greater than? To the right. You're right. I didn't do a test for that one because I kind of don't have to. I just read it. It doesn't have a y to get in the way. I just know, oh, where's x bigger than -3? This way. Question? If there's 3, you have to graph the zone for all 3. I have to be able to clearly see that you understand that the answer is, so let's see, down from the blue line, right from the purple line, down from the green line. So, oh, there, that's already too big. There we go. It's this zone here. Now I'm going to show you how Desmos does this. Desmos doesn't have the ability to look at 3 different shadings and judge where that is. It's just going to shade them all. So I'll give you a sec to catch up to me, and then we'll take a look at our technology here. So Desmos shades all 3, and you have to kind of be able to tell where they overlap. Okay, question? One more time? Yeah, we'll get to that. Okay, so, we ready? Can I move on to Desmos here?
Yeah.
Okay, so if I was using Desmos for this question, let me go to Desmos. Desmos. Oh, that's not the right. Oh, did I not? I thought I had these ready to go. Oh, I did have them ready to go, and I erased them. All right, I'll type them in. Okay, so negative 3y minus x is less than, no, sorry, is greater than 6. There's the first one. The second one is x is greater than or equal to negative 3. The third one is y is less than or equal to 4/3. And then remember this, when you're doing Desmos, if I start typing, wow, what happened? Oh, it thinks x is in the denominator. I don't want it to think that. So move your cursor over one place, then hit the x. And then from there, what am I doing next? +4. Okay, let's get all the keyboard out of the way. That's really hard to see, isn't it? Where's the zone where all of them are shaded? You know what? I might make my life easier. I can go to settings. I can go to settings, and I can change black's color to maybe something that isn't so dark. There, is that better?
Yeah.
There you go. In here is my answer. I have another strategy for you.
Okay.
If you start, what if I had a 4th and a 5th equation here? Now it's going to be really hard to tell what's all 4 or all 5 things shaded. What if we did the opposite of everything? What if I changed this greater than to a less than? What if I changed this greater than or equal to a less than or equal to? And what if I changed this less than or equal to a greater than or equal to? Yeah, now do you see how easy it is to see where the answer is?
Okay, what?
It's the place that isn't shaded, right? There's mine again.
You just switch the greater and less.
I just switch everybody around when I'm graphing. That is, by the way, the only way you'll make this work on a TI. Because the TI can only shade with horizontal and vertical lines. So
if we
do everything graphed its opposites. Here, I'll run through it with the TI. So if I go to my TI, and I say, okay, let me clear all these lines. Clear, clear. And let's start graphing them. So the first one, oh yeah, and don't forget, I can't graph it like this. This one's okay. I'll do him first. 4/3 x plus 4. And I already know, I better go back to my notes here. I know that I have to figure it out for myself. I had to shade, which way I have to? I had to shade down. So I move my cursor over to the shading part and say, no, not you. No, that's shading up. There's shading down. So boom, there's that first one, shaded down. Okay? But since I want the place where they're all meeting and I want it to be clear, change it. If I know I'm graphing a bunch of zones, change it to the opposite that I want. Change it to that one. Okay, now for the next equation, remember I could not put this into the equation on Desmos, so I have to go to this form. So I'm going to go to here. Oops, go to here, move over. So this is -1/3 x minus 2. And what kind of shading do I want? Well, I figured out shade down. There it is over there. Let me move the calculator over. Shade down. But if I want the opposite, let's shade up. So enter, enter, shade up. And now, okay, well, now we've hit a real problem. How do I graph x is greater than or equal to -3? Yeah. How do I do that? It just y equals. It doesn't allow me to type in an x. So you know what I have to do? I kind of have to cheat. This is how I do it. I go to my window, and I'll just make x always be greater than -3. So my x minimum is -3. In other words, I only set that to be the border of the graph. Now hit graph, and there we go. Everything in the section that's about to be clear is my answer. So basically, can you see this? This is my picture right here. I'm just boundarying it right here. And there it is. This white zone here is this yellow zone. The best I can do on a TI if I have to graph x is greater than or x is equal to is make it a window boundary. Another drawback of the TI that Desmos doesn't have a problem with. Okay? All right, so people think, like, does Desmos pay you? It's like, no. No, I just happen to. I mean, we've had personal computers on our desks since the 1980s, and really, it's only been in the last 6 or 7 years that Desmos is like, this is now the best graphing technology, especially for people at our level, right? Yes, if you want fancier stuff, like you're in 2nd and 3rd year calculus, you might prefer Wolfram Alpha, but for those of us doing high school and early university math, really Desmos is the best anybody's come along with. It's really good stuff, so we like it. So, and I love this, it is kept free. You don't have to watch ads, you don't have to pay anybody for it. Their mission statement as a company is that it will be free, which is cool. These calculators cost $140, unless of course you just, All right, anyway, let's move on to another one. This one's a lot of fun. This one is easy, isn't it? Okay, let's do this one quick.
Because it just gives us the numbers.
All right, so basically all of these lines are horizontal and vertical. I'll do different colors again. All the colors of the rainbow. So this one is y is greater than or equal to 2. So that's a solid line. I'm going to make this fatter. There we go.
During the test, we don't. What you want to see is like.
Desmos, yes. You're using. The question is, can we use Desmos during the test? Yes.
Desmos, like, do you want us like to use other like kinds of like pencils or pens?
Nah.
The graph?
Shade up. Y is less than 8. I'm going to make this one green. Where is 8? There's 8. What are you expecting but from all this?
Colorful.
What are you expecting? You're thinking it's a square? Let's see if you're right. Shade down. X is greater than 1. I'll do this one in purple. So remember, X lines are up and down. So X is greater than or equal to 1. So here's 1. And we're shading to the right because we have to be, whoops, I just misspelled shade. Shade to the right. And then less than 7, I'll do this one in red. So 7, 10, 9, 8, 7. And this one is shade left because you have to be less than 7. So we are right of the purple line, left of the red line, down from the green line, up from the blue line. I think we made a square. Is it a perfect square? Is it 6 in every direction? 1, 2, 3. Yes, it is. Haha, isn't that cool? There we go. That one's fun. I like that one. Nothing to, oops, got rid of my shading. There we go. Now, since this is an easy one, why don't I ask you a question? Why don't we add to this one? Determine 2 points within the solution set. Now this is one of those open response questions. Oh, how about this? Let's add something to it. If X and Y, ooh, what does that mean again? So don't give me fractions. So give me whole numbers that are in that solution set. How about, and you can give them to me as points. Remember, X always goes first. How about this one? How about that one? That would be the point 2, 3. That's an answer. Oh, how about this point up here? What's that point? 5, 7. That's an answer. Can I take numbers that are on the lines? Yes, because they all have equal to's on them. Good. That didn't fool you for a second. Good for you. So I could pick this corner. That's an answer. What's that corner? That corner is 7, 8. And of course I'm going to say etc. It's not infinite. There's not infinite answers. If I didn't put this, if this W was an R, there's infinite answers, right? Because there's an infinite number of fractions and decimals you can find between any 2 points on a number line, right? Okay, so there we go.
We're just finding the points.
Just finding points that are in the zone.
Okay.
We're going to be working on that later because now, guess what we move on to now? Now we move on to applying this stuff. Hey, they call this applied math for a reason.
No.
A company makes backpacks and briefcases. They are not allowed to make any more than 20 backpacks and briefcases in one day. A maximum of 10 backpacks can be made in one day. A maximum of 15 briefcases can be made in one day. So in other words, they have these machines that they probably have to set up to make backpacks or briefcases. And the machines work at a certain rate, so there's only so many they can make in a workday. That's the idea. Determine all the possible numbers of backpacks and briefcases that can be made in one day. So, A, define the variables. Okay, well, define means tell me what they mean. So I'm going to say let X equal number of backpacks made. And I'm going to say let Y equal number of briefcases made. Oops, and I just misspelled briefcase. There we go. So there we go. It told me to use X and Y, so I did. Write the system of inequalities for this problem. There's 5 of them. Yes?
10x plus 15 y is
Okay.
are equal to 20.
Not quite. How about you're on the right track. Okay, here's the first statement. Let me go back to the question. They're not allowed to make any more than 20 of both together in a day. So X plus Y together has to be less than or equal to 20. Now why equal to? Because it says any more than. They can make 20, but they can't make more than that. Now that's together. What if I only made backpacks today? What's my maximum I could make? So what is that telling me? X has to be less than or equal to 10. What about briefcases? Y has to be less than or equal to 15, isn't it? 15 is the briefcase number, right? Go back to the question. You got to read them carefully. Yep, 15. Okay, now I actually do kind of have 2 other ones that are implied. There you go. Somebody's figured it out. There's 2 implied ones here. What if you go to work and say, well, hey, X plus Y has less than 20. Hey, Y could be 21 and X could be -1, and that makes this equation work. But it's not logical. What, are you going to show up for work and make -1 backpacks today? No. So X is greater than or equal to 0, and Y is greater than or equal to 0. These ones are implied by the situation. Please don't come up to me after and go, where did you get those two equations from? I don't read that in the question. Well, you do read it in the question because it only makes sense logically that you can't show up to work and make negative numbers of products. Well, maybe at your job, but I think most people.
Unless you're bad at your job.
Okay, now.
Unless you're good at your job.
Also, it makes sense that we're not going to have decimals and fractions of briefcases and backpacks. So that puts implicit constraints on my variables. My implicit constraints are, I should probably use a curved bracket for that, is that x and y, we probably shouldn't be playing on our phone, have to be what kinds of numbers? They should be whole numbers. I'm going to say whole, not integer, because no negatives. And I'm going to say whole, not natural, because one of them could be 0. We could show up today and make nothing but backpacks. 0 for the briefcases. So we're going to say elements of whole numbers. That's my implicit constraints. I guess some people might put this down here too. Because, again, implied and implicit mean the same basic thing. All right.
How would 2.5
As long as you have that, it doesn't matter like where you put it.
No, it wouldn't matter to me. Okay, question next. How do we graph this? All right, well, this one, again, this is an example of one that I think you could do by hand. Right? So x, let's do the vertical and horizontal first. X is less than or equal to 10, right? I don't know, I guess it didn't photocopy so great, but who cares? You can see it. X is less than or equal to 10. That's this line here. Pretend I could draw a straight line. And of course that would be shade left. And then the next one was, what was the briefcase one again? 15. Y is less than or equal to 15, and this one would be shade down, right? Because down is less than when you're on the y-axis here. So 15 is this way. So all of my answers are in this left rectangle here. Thank you. Okay, now we have to deal with the line that's oblique. X plus y is less than or equal to 20. Again, I'm a big fan of the y equals mx plus b school of doing these. So I'm just going to minus x from both sides of the equation. And I have a y-intercept. I'll do this one in a different color. I'll do this one in blue. So I have a y-intercept of 20, and my slope is negative 1 over 1. So down 1 over 1, down 1 over 1, down 1 over 1. I think you see the idea here. Now I'm going to try to draw this even though I can't see all of the corners because this thing kind of... Okay, and that's good enough. I already know that all my answers are in this rectangle, but do I want this area or this area? And my pen just died. There we go. So which area do I want? I better do a test. I don't know. So let's test. Does 0, 0 make this a true statement? 0 is less than or equal to negative 0 plus 20. The negative 1 times 0 still is 0. So is 0 less than or equal to 20? Yes, it is. So we have to shade to include 0, 0. So we shade left. Now, having said that, my implied axes here, notice I'm only in one quadrant on this graph because, remember, these are equations too, right? You can't be smaller than 0. So there's that one. Did you know that the x and y axes actually have equations that describe them? The x-axis is y is equal to 0, and the y-axis is x is equal to 0. So I'm within this section. And there it is. That's how we do this kind of problem. So shade that, and then we'll move on to the next problem, and then we'll call it a day. One more example today. Okay, questions, first of all. Yep. Okay, so somebody wants me to go back to D really quick. This is D. That one? All the way up. So you want to go to A? Oh, the other D. So this question, okay. You know what? We'll go back to it later. I don't want to kind of disrupt the flow of what I'm doing here. Okay, so now this is basically the same question I asked you on that D that you were just asking about. Give me one solution to this problem. There you go. Somebody realized, hey, wait a minute, you just shaded everything and you just told us we got to be whole numbers. You know what, guys? When I mark your test, I'm happy with that. Please don't waste 10 minutes of your test making dots. Technically speaking, you should, because all of the yellow zone isn't really all the answers. All the answers are actually these corners, right? I know. Let's give you a really tiny zone. Now, it actually does say to determine one solution to this problem. How many solutions are there? There is, let's see, there is 15 by 10 minus whatever all those dots are. So there's 150 minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 150 minus 12 or so, 150 minus 15 or so. So there's a lot of solutions. Give me one. Give me a solution. Okay, now, read what that says. So he picked 5, 7. That's a perfectly nice solution. I agree with it. But if that was the instructions, I'm not giving you full marks. Because what are you supposed to do? Therefore, they could make, and if you said they could make 5, 7, well, that's not good enough. They could make 5 what? What was X again?
They could make 5 backpacks.
5 backpacks. And 7 briefcases. Now, before we leave this problem, suppose a new constraint came in. Suppose they got a phone call from one of the stores that they're a supplier for, and they said, "Hey, well, the backpacks are flying off the shelves right now. Well, we need more, and you know the briefcases aren't selling so much. Can you adjust your production so that you give us more backpacks and less briefcases?" Where would I look for answers? Okay, I wouldn't pick 5, 7 now. Not that it's a bad answer. It's a perfectly nice answer. It's a very nice dot in the middle of that C there. But how about if I want to increase X and decrease Y? Well, I guess, oops, oh, go away. I guess I could totally pick this corner right here. But then I'd be saying to my store, okay, well, I could make you 10 backpacks a day, but then you're not getting any briefcases. And they say, well, we sell some briefcases. So wouldn't maybe the best point be right here? 10, 10 of each? That might be a good point. Now, what if instead of the store phoning me and saying, we just need more of this than that, what if the decision as to what point I pick is based on how much profit I make from each thing? That's where we go in the next part of the chapter. Okay, so anyway, that takes us to our last example. We'll try to get through one more today here. Actually, you know what? I've changed my mind. Let's save this example till tomorrow so that we do one more together tomorrow. But you should be able to try the rest of the assignment here. So let's see. So I'm going to close the video from here. See you later. So, okay, so thanks for watching. We'll do this last example in tomorrow's video.